Everyone, if you have not already, please take a second and look over these notes. So these are just some things to know. A lot of it we've already worked with. However, we are going to move on to vectors. And so if you're unused to seeing things written with these brackets here, it is a vector. Obviously here we're going to start with position and we're going to move on to velocity, which is the derivative, and acceleration is the second derivative. Okay, now you already know some things like rate of change of the change, a rate of change, or rate of change of the slope. So that's what we refer to as concavity. Now notice the similarity here between my two equations, okay, where the square root of my derivatives squared and added is the speed of my particle, or we sometimes call that magnitude of the velocity vector, right? And the integral of velocity is distance traveled, or arc length. Okay, so or you could think about the derivative of arc length, so without the integral, is my velocity, or my speed, because it's squared and square rooted. Right, so the integral of my derivatives is going to be arc length. So that's what we talked about in the last notes. All right, so let's move on to actually doing some vectors. All right, so first they give us an example where a particle is moving, and at any point in time, it can be modeled by these equations. So it wants to know what's going on with the velocity when t equals 1. Okay, well, I'm given position, so I need to find my velocity. Okay, well, my velocity vector is going to be given as I need to take the derivative. So I get 6t squared minus 10t, and then I get 8t cubed plus 3t squared. And now they want me to evaluate at 1. So I'm going to plug 1 in. So I have 6 minus 10, which is negative 4. And I have 8 plus 3, which is 11. Right, then they want me to find the acceleration vector when t equals 1. So I have to take the derivative again. Right, so we'll take the derivative one more time. We get 12t minus 10. We get 24t squared plus 6t. Right, now I'm going to plug in 1 once more. So I get 12 minus 10, which is 2. I get 24 plus 6, which is 30. Right, and I'm done. This is my answer. All right, question is, how do I find the magnitude or the length of a vector? If you've worked with vectors, you know that we do a lot of triangles. So I'm going to think about my position vector in terms of Cartesian coordinates, in which you really only move right, left, up, down. Okay, so I'm moving horizontally in terms of x, I'm moving vertically in terms of y, and so this diagonal line can be represented by, you probably guessed, you could think about this as the distance formula or Pythagorean theorem. Right, so I have x squared plus y squared and a big old square root. Right, so as you can see, I have a right triangle here. So this is the distance formula, Pythagorean theorem, same thing. Right, now they want me to discuss the magnitude of the velocity vector. Well, same deal here. Right, so I'm still moving to the right or to the left here, except this is x prime of t, right, and this is y prime of t, because we're in terms of my derivative now, because this is velocity. And so the exact same thing, x prime of t squared, y prime of t squared, inside a square root. Right? And the magnitude of velocity is called speed, because it's always positive. Right, the sign doesn't matter as much there. Right, and one more, we're going to do acceleration. You can probably guess how to do it. Okay, this is in terms of x double prime. This is in terms of y double prime. And once again, square root x double prime of t squared, y double prime of t squared, and that is my magnitude of my acceleration. Right, so same thing for all of them. Okay, they give us a particle, And the position is as such. They want us to find the magnitude of the velocity vector when t equals 3. Well, I do not have the velocity, I have the position. All right, so I need to figure out my x prime of t and my y prime of t, so I can put some perspective on this. So first thing I gotta do is figure out my velocity vector, which is going to be the derivative here. Okay, so I need to find x prime of t and y prime of t. Okay, well, my derivative here is going to be 2t plus 5. My derivative here, well, you take the derivative of the inside, put that on top, and then you divide by your inside. Okay, they want me to evaluate this at 3, so I need to figure out what's going on with my velocity at 3. I plug 3 in, I get 11. I plug 3 in here, I get 6 over 13. Okay, now we're going to use our Pythagorean theorem again. So my magnitude, which we can, that's ugly, which we can use this to represent, sorry, that should be a 3, right, is going to be the square root of 11 squared plus 6/13 squared. All right, I'm not going to simplify that. All right. Some more word problems. Okay, we're given a particle. Okay, we have x and y, and we're restricted between 0 and 2 pi, which is good because this is trig. Okay, the path of the particle intersects the x-axis twice. What that means is that y equals 0 twice. They ask us to write an expression representing the distance traveled by the particle between my two x-intercepts. So I need to figure out where my bounds are, essentially. So I need to figure out these two x-intercepts, and I know that those exist where y equals 0. So I'm going to take my y equation and set it equal to 0. Right, so that means that sine of t has to equal 1/2. You do arc sine on both sides. I'm restricted to 1 revolution, so I get that t is pi over 6 and 5 pi over 6, because that's where sine is positive in the first two quadrants. All right, they want me to write an expression of the distance traveled. Okay, that's arc length, and for arc length you need to find your derivatives. So I need to write out my velocity vector, or simply find the derivative of x and y. So the derivative of x is going to, that'll go away, is going to be, it's going to be positive 4 sine. Right, and the derivative of y is going to be negative 2 cosine of t. Right, so now I'm going to use this to find my arc length. So I'm going to write L equals integral from pi over 6 to 5 pi over 6, because those are the bounds that I found here, square root, and I'm going to square both of my derivatives with respect to t. All right, so you could distribute this squared here if you wanted to. All right, they said do not evaluate, so I'm not going to evaluate. Okay, now they're asking when is my particle at rest. So they give us a lot of position information here. They say that t has to be greater than or equal to 0. They ask us when this is at rest. Well, I know that a particle is at rest when its velocity is 0. Okay, that means it's not moving in either direction. So I need x prime of t to be 0, and I also need y prime of t to be 0. Okay, well, we have to find our derivatives. So my derivative of x is going to be 6t squared minus 30t plus 36. My derivative of y is going to be 3t squared minus 6t. All right, so I need to solve both of these out. And so if you end up solving this out, you factor 6 out and then factor, you end up getting that t equals 3 and 2. Okay, and then for y, we end up getting that t equals 0 and 2. Okay, now what we want is for both of our values to be the same. Okay, just because x is not nothing's moving in the x direction at 3 does not mean that y is not moving at 3. Okay, so we could not be moving laterally, but we could be moving vertically at 3. Same thing at 0. Okay, I'm going to be not moving vertically at 0, but I could be moving, actually I am moving laterally in some way. However, at 2, I'm not moving in the x direction, nor am I moving in the y direction. Right, so t equals 2 is going to be where my particle is absolutely at rest, when my velocity vector is 0 and 0 for both x and y. Okay, last one. Okay, I have a particle. Again, I'm moving, and this time I'm given my velocity vector. Okay, at 0, they give me my initial starting position. They want to find the position at 1. Okay, so now I need to go backwards. Okay, so I need to find x of t, which is going to be the integral of x prime of t. Okay, kind of obviously. So let's integrate. So I'm finding the integral of 3t squared minus 4t with respect to t, which in this case is going to be t cubed minus 2t squared. And gotta remember that plus c. Okay, now I also have to do the same thing for y. And so my y value, or my y part of my vector, is the integral of y prime of t. So integral of 8t cubed plus 5 with respect to t. Okay, that's going to be a little bit more. We get 2t to the 4th plus 5t plus c. Okay, so that's what y is equal to. Now I got to get rid of these c's here, and the nice thing is they did give us an initial value. All right, so I know that 0, when t is 0, x is equal to 7 and y is equal to negative 4. So I can plug 0 in for t, and know that that will equal 7, which means that c equals 7 because that's my initial value. Okay, c is always going to be your initial value, actually. So if you don't believe me, you can work it out. If you plug 0 in for t, these terms go away, and this is equal to 7. Same thing here. Okay, c is going to be equal to negative 4 because that's my initial value for y. Okay, so this is going to be my position vector. And I want to evaluate this when t equals 1. Right, so I'm just going to plug 1 in. You end up getting 6 and 3. All right, that is it for these notes. I'll see you all later.